Alright, today we're looking at inverses of exponentials and logs. So the process is really no different to inverses of anything. So to find the inverse of a function, you swap the x and y, rearrange it. So you do exactly the same for exponentials and logs. So written in function notation. You get that. Alright, so it's a function f, domain is the real numbers, codomain is also the real numbers. So function is e to the x plus 2. So we're going to find the inverse of that and state the domain and range of the inverse.
Why?
Alright, so if we write it like this, y equals e to the x. So same as anything else when we're working out the inverse, we swap the x and y and then we rearrange. So e to the y plus 2. So now we've got to rearrange to get y equals. So first step would be move that 2, and we do that by subtracting the variable. Alright, now we've got e to the y over here, and we need to get rid of that e and get rid of this power, get the y down.
How do you do that?
How would we do that?
Square root of times one?
Like the square?
Oh, that. Yeah, totally forget it.
If we take log base e, then what can we do with that? Stick it down the front. Log e of e is 1. So that's what we do. So we do log, and because that's an e there, that's why we use log base e. If that was a 5 there, we'd do log base 5. So log base e of x minus 2 would be log base e of e to the y, and the y comes down.
Do you keep the log on that side?
Alright, so now of course we just put this y in here for convenience when we're working it out. So we need to write it in the function notation. So inverse in function notation is f minus 1 of x, and that's log to the base e of x minus 2. So it's important on the exam, if you just leave your answer like this and don't put this notation, you won't get full marks. And also remember on the exams there's no half marks, so leaving it that rather than putting that's going to cost you a whole mark. Alright, the second part was the domain and the range. So if I just look at f, for example, our domain is R, the real numbers. The range, however, is what? So f is e to the x plus 2. What can you tell me about that?
That's a translation.
Translation, up 2. So we've got our asymptote there of 2 for that e to the x plus 2. And then where is it? Above or below the line?
It's above.
Above, so it's up there. So the range of that is what?
2 to infinity.
2 to infinity. Now, what's the relationship between the domain and range of our inverse and the domain and range of our original?
Okay, this swap.
They swap, exactly. So
Oh, that was in
for f minus 1, our domain is 2 to infinity. Oops. And our range would be all the real numbers.
Wait, what's that, the Y, the little arrow Y thing up the top? What's that?
All right, because one of our log laws says that if we've got the log of something to a power, that we can move that
How is
power down the front. All right, let's do another one. I've got two more examples. All right, so the process for finding the inverse is really no different than anything. It's just we're using exponential and log functions. So, all right. So to find the inverse, do the same thing as we did before. Swap the x and the y. So I'm going to do that straight away. So instead of fx or y, we're going to have x there. Up to the base c, y minus 1 plus 3. All right, so which thing do we need to move first? The 3, all right. So that should then be x minus 3. It's 2 log to the base e of y minus 1. The next thing we move is the 2, yeah, because it's 2 times there, so we need to move that first. So we've got x minus 3 over 2 log to the base e of y minus 1. And now we move the log, and to remove the log we do e. So e to the power of x minus 3 over 2. So that's then just going to leave me with the y minus 1. Alright, and then add 1 to both sides and you find that y equals e to the x minus 3 over 2 plus 1. And don't forget to write inverse notation, so f minus 1 of x. You get that. Alright. So in this particular case, what is the domain?
Domain.
Of our inverse?
Well,
Infinity.
won't it be
Because they swap down
They
there.
swap, that's right.
Infinity.
So it's going to be r. Remember a log graph looks like that, doesn't it? Alright, so the range of a log graph is r. So when we found the inverse, our domain is now going to be r, because remember, we've now got our exponential graph that goes that way. And our range will be, because they swap, 1 to infinity. Alright, so for the inverse, they simply swap. Now, if you are concerned about this, rearranging this, you can get your calculator to help you. If you go to solve, so you can either do that in not transformation, in the advanced solve, and you can ask it to solve
because it's
x equals 2, and you need from your keyboard ln. ln is log base of e, and it's y minus 1. And if you ask it to solve for y, it will rearrange for you. So there's your answer. Oh, I forgot. What did I forget? I forgot the plus 3 on the end. Let me fix that up. That equals 3 plus 3. That's better. All right, again, just be careful of calculator. If you do use your calculator, how it writes it. Like this here, ugly looking. So if you, this button here, the simp button, if you just click on that, it will automatically simplify whatever you've got there as your answer. You don't need to. This button here,
Do we have it?
it will simplify it. So that's written now more like what we'd be used to. So just be careful with your calculator.
Oh, we do.
You also will want it in standard, because if it's not in standard,
It'll come out and then come on.
that'll come out like this.
Ooh, fun.
All right. Which is not very nice looking, so make sure you've got your calculator set in standard.
Y equals e to the power of x take 3 over 2 doesn't exactly look nice either.
Oh yeah, it does, much nicer.
Right. Now, sure. Is
All right.
this by-
One more question. All right. The other thing you might be asked to do, other than finding just inverses, is just to rearrange, make some other thing the subject.
What does subject mean?
Oh, like T equals.
All right, so we're just asked to rearrange this, not find an inverse or anything.
Okay.
All right, so we just want to make t the subject. So here's the t here, we've got this k, we've got this e to the power of, we've got this a here, so we just need to move these things. So which one are we moving first?
The A.
The a,
Yeah.
yep. So p over a equals e to the kt. Yeah, we need to get rid of the e to the power of bit.
Gotta make a log.
Take the log, yep. So that's p on a. So that leaves us with kt. And the last step,
Divide by K.
divide by k is correct.
Hang on, so it's like the log gonna be divided by k.
Alright, you can write it
Yes.
like that, but more often than not you'll see that written in this way, where you have 1 on k at the front and then log base e of p on a.
That's
Oh.
what your calculator would come with, wouldn't it?
I like
Probably.
the
This is much nicer looking
It
than that
looks
one.
much
I like
nicer to
the top.
write. I mean, but if like,
Alright, so that's it. Unless there's anything that I went over too fast that anyone wants clarifying. Alright, so that's exercise 5H. Right, now before you all get